Welcome children to this session. Yesterday we have seen the introductory part of this lesson gravitation children, and the major difference between acceleration due to gravity, that is the term gravity, and gravitation, the law of gravitation, etc. we have seen children. Quickly, we will revise what has been taught yesterday, children. First, we have seen the introductory part, that is geocentric, heliocentric theory. Geocentric theory says that Earth being the center, all the planets, including the Sun, move around the Earth, which was proposed by Ptolemy. Heliocentric theory, Sun being the center, all the planets move around the Sun, what that is existed today. Then much statistical data was collected by Tycho Brahe. Johannes Kepler takes the help of Tycho Brahe and proposes the laws of Kepler, laws of planetary motion. Sir Isaac Newton studies these laws of planetary motion and he gives one law called law of gravitation. Centripetal force. Any object which moves along circular path will have this force, because when a body moves along the circular path, its direction changes continuously. Therefore, the body is said to be accelerated. So, the force that is directed towards the center, which causes acceleration and gives the body to move along the circular path, is known as centripetal force. Gravitation, the word children, the force of attraction between any two objects in the universe because of their masses is known as gravitation. Gravity is the force of attraction between the earth and the objects on the surface of the earth. These two definitions you must be very clear about. Gravitation is the force of attraction between any two objects because of their masses. Gravity is the force of attraction between the earth and objects on the surface. Law of gravitation, very important children. You have to remember this law of gravitation and the formula related to this. Every object in the universe attract one another with the force which is directly proportional to product of their masses and inversely proportional to square on the distance between them. Mathematical representation children, M1, M2 or capital M, small m are the masses of the objects. The force is directly proportional to product of their masses, inversely proportional to square of the distance between them, where G is called universal gravitational constant, which was proposed by Henry Cavendish, whose value is said to be constant 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Free fall, falling of an object from a height towards the earth under the gravitational force of the earth is known as free fall. When a body falls freely from a height, it undergoes uniform acceleration. Velocity increases by equal amounts in equal intervals of time. Acceleration due to gravity. The uniform acceleration produced in a free-falling object due to gravitational force of the earth is called acceleration due to gravity. This acceleration due to gravity is represented by small g. Its average value is found to be 9.8 meter per second square children. G is maximum at the poles, minimum at the equator. Yesterday we have discussed, children, this is due to geoid shape of the earth. The value of G on the moon is about 1/6 of value of G on the earth. Children, we have seen in the lesson describing motion the three equations of motion. The terms are final velocity, initial velocity, acceleration time taken, and displacement. All these terms are related by set of equations called equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. These are the three equations of motion. These three equations of motion change into A becomes G, where G is known as acceleration due to gravity. Yes, the displacement becomes height, children. These are the changes that we are going to do it. Equations of motion for free falling objects. When an object falls towards the earth, understand this, children. When the object falls towards earth, we have to take this G as positive. When an object is thrown away from the earth, projectile we say, when an object is thrown from the earth, G becomes negative. Therefore, free falling object, A becomes plus G and S becomes H, height, children. Acceleration due to gravity, A becomes G, 2AS become 2GH, children. This is for free falling objects. This formula will help us to do the sums based on this lesson, children. When the equations of motion for projectile, when an object is thrown vertically upward from the earth's surface, G becomes negative, children. Therefore, V is equal to U minus GT, H is equal to UT minus half GT square, V square is equal to U square minus 2GH. We must know when to place plus, when to place minus. The two differences I have given, children, regarding these two, we have discussed earlier itself, children. Acceleration due to gravity, G. G value varies, we have seen. G value is maximum at the poles, minimum at the equator, whereas G value is always constant. SI unit is meter per second square. This is Newton meter square per kg square. Average value of the surface, value on the surface of the earth is about 9.8 meter per square. The value is 6.67, 10 to the power of minus 11 Newton meter square per kg square. This acceleration due to gravity, it is a vector quantity, it is a scalar quantity. These are the few differences you need to know from this lesson, children. Now we have a very special concept, that is mass and weight. In our day-to-day life situation, children, we consider and deal and take it both as same, mass and weight. More or less, we use these two terms for the same purpose. But it is not the true thing. Mass is different, weight is different. We are going to see in this part very clearly what is the difference between mass and weight. The typical definition of mass: the quantity of matter contained in the body is called mass. The quantity of matter. To make a better understanding of this definition, children, quantity of matter. We know what is matter. Matter, anything which has mass and which occupies space is known as matter. So this is very clear. The quantity of matter. How much? Consider a bag which consists of 10 stones. For example, simple example I have taken. A bag which consists of just 10 stones. Each stone weighs about 1 kg. Therefore 10 kg. The SI unit of mass is kg. The quantity of matter contained in the body is called mass. The mass remains same throughout the universe. The value will not change. The definition part. The next. These are the 4 important points you need to remember. SI unit of mass is kg. Quantity of matter contained in the body is called mass. SI unit of mass is kg. Mass of the body is constant at all places. Wherever you take the bag which contains 10 stones, it will remain as 10 stones only. It will not be 9 or 8. Even you carry that bag to the other planet and count the number of stones, it will be 10 only. There will not be change. The quantity of matter will remain same at all places. So mass of the body is constant at all places. It is a scalar quantity. Mass of the body cannot be zero. These are the points you need to be remembered, children. This is regarding mass. Definition: SI unit. Mass of the body is constant. It is a scalar quantity. It has got only how much, but no direction. How much? 10 stones. Mass of the body cannot be zero. The second one is weight. Weight. See, the definition of a weight goes like this. The force. See, the word which is used, children. Weight is nothing but the force, which means weight is equal to force. What is the SI unit of force? Newton. Therefore, SI unit of weight is also Newton. This is the big difference between mass and the weight. Mass is kg, but weight is Newton because it is a force. Weight is a force with which an object is attracted towards the center of the earth is called weight. The force with which an object is attracted towards the center of the earth is called weight. Try to learn this statement, children. SI unit of weight is Newton because weight is nothing but the force with which an object is attracted towards the center of the earth. Weight is a vector quantity. Just got both magnitude and direction. Weight of a body is not constant. Weight differs from place to place because F is equal to, weight is equal to F. F is equal to m into A as per Newton's second law of motion. M into A, force, and F is equal to m into A, mass into acceleration due to gravity. That acceleration due to gravity, A can be taken as small g. Small g, its value is not the same we have seen, children. Its value is maximum at the poles, minimum at the equator. Therefore, weight of a body is not constant. Weight of a body can be zero, but mass of the body cannot be zero. Weight on the moon is equal to 1/6 of its weight on the earth. If you are weighing about 60 kg on the earth, if you go to the moon, your weight will be just 6. It will be just 6. Okay, this is about mass and weight, children. Do not get confused. Write down, make a chart, make 2 parts. Write one side as mass and the points, and weight and the points, children. I will revise if it is required, children. Mass, the quantity of matter contained in the body is called mass. SI unit is kg. Mass of the body is constant at all places. It is a scalar quantity. It cannot be zero. The force with which an object is attracted towards the center of the earth is called weight. SI unit is Newton. It is a vector quantity. Weight of the body is not constant. Weight of the body can be zero. Weight, as we have discussed, children, weight is nothing but the force with which an object is attracted towards the center of the earth. Therefore, that weight can be taken as force. We know that from the second law of Newton, F is equal to m into A, mass into acceleration. M is taken as such, the acceleration due to gravity becomes g. If mass is equal to 1 kg, then weight is equal to m into g. Mass is equal to 1 kg. Acceleration due to gravity is 9.8 meter per second square average value. Therefore, weight of 1 kg is equal to 9.8 Newton. This is how the calculation part goes, children. Note, the mass of the moon is about 100 times and its radius is about 1/4 times that of the earth. Mass of the earth is equal to 100 times mass of the moon. Radius of the earth is equal to 4 times that of the radius of the moon. As a result, children, the gravitational attraction on the moon is about 1/6 that of the earth. Next, children, we have got the two important concepts, that is thrust and pressure. This is not a new term to you, children. You have studied in your 8th standard, pressure. I have taken few examples. You can try out these activities at home to feel the better understanding of this term pressure. What are those? First one, a sharp pencil caught between two fingers. A sharp pencil caught between two fingers. Press it from each side with equal force. Okay? A sharp pencil, the sharp end at one side and the flat surface with the other end. Press it both. On which finger do you feel the pain more? The sharp side. Pain will become more than the flat surface. On which finger does the pencil leave a deeper mark? You can test and see the sharp side, because area is less. Observe the depressions in your fingers. Hammering an iron nail. Nail, children, which has got two faces. One is a sharp face, another one becomes a flat face. A sharp face is usually placed on the wall, which is hammered on the flat surface. It's a flat face and a pointed face. Pointed face is kept on the wall and hammered on the flat surface, because the pointed surface has got smaller area, which finds easy to penetrate into the wall than the flat surface. Knife, which has got two edges. One is cutting edge, which is very sharp. Another is a blunt edge, which is not very sharp. The cutting edge has got less area, children. You can check. Cutting edge has got a short edge, which has got less area, okay, which causes more pressure on the objects. Therefore, things can be sliced easily with the short end. A sharp knife cuts things better because due to very thin edge of its blade, the force of hands falls on very small area of the object being cut, producing high pressure. Children's school bags have wider belts or straps, children. Wider belts or straps which reduces pressure on the shoulder. Imagine if the shoulder belts are very small like wire, which will cause much pressure on the shoulder, children. Therefore, almost all the school bags have wider straps. Larger area falls on the shoulder, which reduces the pressure. If area is more, pressure becomes less. The bag we have discussed, children. This is the strap. Large-footed animals easily walk on the loose sand. Okay, camels. They walk very freely on the sand because large-footed area becomes large, therefore, which will not sink into the sand very deeper. Area becomes more, pressure becomes less because large foot reduces pressure. Large flat foot of camel. See, here log which is taken drawing pen and it is pressed. See, one is a pointed end, another which is a flat end. The pointed end is placed on the drawing sheet or the display board and it is pressed by this. Larger area, smaller area, which causes larger pressure and gets in. Therefore, in all these cases, children, we find a relation between pressure, force and area. If area is less, pressure becomes more. So how do we define pressure? Force acting per unit area. The force acting on unit area is called pressure. Definition part. And formula, pressure is equal to force by area divided by area. SI unit of force. SI unit of force is Newton by area is meter square. Or this Newton per meter square can be taken as Pascal. There is a particular way of writing this, children. All the letters must be small. Pascal. Or this Pascal can be written as capital P, small a, PA, Pascal. These are the ways we represent its SI unit. In honor of French scientist Blaise Pascal, the SI unit of pressure is called Pascal. So, the force acting per unit area is called pressure, children. Pressure is equal to force divided by area. Formula part is over. SI unit is Newton per meter square or Pascal. What is then thrust, children? If a force which is acted on a surface perpendicularly, how the force? Perpendicular force on the surface area. If the force which acts perpendicular to its surface, then we call that force as called thrust, children. Another name called thrust. Fixing a nail to the wall by hammering. It is perpendicular, children. Perpendicular surface. Standing on the loose stand or even standing on the ground, okay, is perpendicular. Drawing pins are pressed with the thumb perpendicular to the board. These are the examples I have given. Therefore, the definition part. The force acting on an object, how? Perpendicular to the surface is called thrust. Very clear. The force acting on an object perpendicular to the surface is called thrust. SI unit of thrust is Newton, because this is nothing but the force. How the force? Perpendicular force. Therefore, its SI unit is Newton. Fluids, children. This is a very common term. Fluids. Substances which can flow easily are called fluids. Simple definition. Substances which can flow easily. Example, liquids and gases are the examples for fluids. All liquids and gases are fluids. Substance which can flow. A solid exerts pressure on the surface due to its weight. Similarly, fluids have weight. Therefore, they also exert pressure on the base and walls of the container. A fluid exerts pressure in all directions, even upwards. One simple activity you can try at home, children. What is that? Take a bucket of water, take an empty water bottle, put the lid tightly and try to place inside the water. Take the bottle to the deeper part of the bucket and leave it. What will happen? It is pumped outside with a greater force, which means the water exerts force on the bottle. That is nothing but upward force. We call that as upthrust even, or a new word, buoyancy or buoyant force. See, I have taken a cork which floats on the surface. Using the thumb, small force is applied and it is pushed into water. Cork. It experiences an outward force. When it is released, it will immediately come to the surface and stand, which means this water exerts an upward force on this cork. So children, till now we have seen many concepts such as mass and weight and fluids, the examples of fluids, the difference between mass and weight, etc. we have seen, children. Please go through these concepts and make a note in your neat notebook, children. Refer the textbook. Please go through the textbook and try to do the activities which are mentioned in the textbook, children. The remaining part we will see in our next class, children. Thank you. Have a nice day, children.